Okay, so again, welcome everyone. We are recording this session for further watching offline and for further consultation of all the attendees and other people. I want to be extremely thankful here to 5G Tours team for preparing for very thoroughly for this event. And my role is very simple and clear. I just want to be a good host, giving you the floor for the presentations that you have to give. Very glad to do this job. I have to say before that just a few things on the context. This event is motivated by the cooperation of 5G project with 5G Tours. 5G is one of the ICT 17 platforms, as you all know, supporting a number of ICT 19 projects. And 5G Tools is a very special case of project that is working with 5G in several locations for several use cases and in different uses of the platform that 5G has created. So it's a special pleasure to be introducing this. Today, what we will have is mm, time for watching concrete and actual demos of the work of 5G tours. And I will go immediately to the agenda where we will allocate a little bit of time for questions after each of the slots we have prepared. I think I'm taking as little time as I can as an introduction for this, and I will give the floor in a few seconds to Bell, who will be presenting overall aspects of the project as technical manager of 5G Tours. And that will continue with demonstrations from the project in the different locations and use cases. As you can see here, and we will allocate for time for 1-2 questions after each of the presentations. After that, in an hour and 20 minutes from now, we will be having a wrap up on the session where we expect along the session and for that aspect your collaboration and participation. So that was for the introduction. I want to start by that with giving the floor directly to Bell for this introduction to the collaboration between 5G and 5G Tours, much more detail that I did. So Bell, the floor is yours.
Thank you, Manuel. Can you hear me okay?
Loud and clear.
Okay, perfect. Okay, so thank you very much for participating and organizing actually this webinar. I think I have 10 minutes, so I go to business now. Can you see my screen?
Yes.
Okay. So my mission is to introduce the link between 5G Tours and 5G Eve here in 10 minutes, and then I will leave the floor to a more specific use case implementation. So my name is Belkacem Mouhouch. I'm the technical manager of 5G Tours. And in order to understand the link between the two projects, most of you would know that 5G Eve is a ICT 17 project that is based on platforms in 4 countries: Spain, France, Italy, and Greece. And within 5G Tours, we are using 3 out of these 4 countries, France, Italy, and Greece, in order to implement our 13 use cases. So, as you may know, 5G Eve works with many different ICT 19 projects. One of them is 5G Tours, and here you can see the link between the different use cases and let's say the different verticals and the ones supported by 5G Tours. And in 5G Tours, you have some use cases that are supported fully or heavily, such as multimedia and entertainment and health and wellness. And then you have some that we touch upon, for example, smart airports or transport. So this is how 5G Tours links to 5G. So we switch now to 5G Tours. What's the vision of 5G Tours? So if we suppose, for example, that a tourist is trying to visit a city in Europe, and we would like to make his visit more interesting, so we have use cases centered around the touristic city in order to enable the tourist to visit the museums and to enjoy his time. And then if there is someone that cannot visit, for example, because of this COVID-19, then there is a use case for a remote visit, for example. And then if something happens to this tourist, then we need to get him to the hospital as soon as possible. We need to, fetch the ambulance. We need to monitor his health. So there are use cases centered around this, and we call it the safe city. And then in order to move from and to the airport or around the city, we need to enhance the mobility experience of the user, of this user. So we call this the mobility efficient city, and it's centered around the airport, the navigation, and the use, for example, of parking in the airport, and use cases like that. So this is the vision of the 5G tours in order to improve the citizens and tourists' experience around the touristic, the safe, and the mobility efficiency. So as I said, we use 3 out of 4 countries, not exactly 3 out of 4 cities, because in France there's Sofia Antipolis that we are not using, but we can say that we use 3 out of 4 countries. So we have the Turin city in Italy. It's used for the touristic city use cases. We have Rennes in France that is used for the safe city, and the mobility efficient city is Athens in Greece. And for each city, we have a set of use cases, and of course, each use case has a specific slice type and KPI requirements. But for the sake of time, I will not go through all the use cases. But for example, in the touristic city, we have use cases around the augmented tourism experience, telepresence, or for example, distributed video production. And you can see here that the KPIs and the requirements are different, whether we have a multimedia experience or a different type of experience. For the safe city in Rennes, the theme is safety and the hospital link. For example, if something happens to the user, so we have use cases around remote health monitoring. We have use cases around wireless operating room. We have also use case around the ambulance routing in case we need to get the patient to the hospital as soon as possible. And for the mobility efficient city in Athens, we have use cases centered around smart parking, for example, or emergency airport evacuation in case we need to evacuate the airport in a quick manner. So these are the 3 cities. And now we will see how 5G Tours approaches the project in order to, let's say, meet all the 13 use cases requirements. So we have actually many inputs to the 5G Tours project, at least 3 inputs. One input is the previous EU project 5G Monarch and 5G XCAS, sorry. So 5G Monarch and 5G XCAS are phase 2 European projects with innovations around orchestration technology and broadcast technologies. So these 2 will fit into the 5G Tours architecture. And there's another component, which is the new innovations that come from 5G Tours. So these are the 3 components of innovation that will fit into the 5G Tours architecture. And then in order to support these use cases, we need an infrastructure provider, and the infrastructure comes from the 5G project, which is the ICT 17 project that we are working with. And using the 3 inputs, we try to work with verticals, of course, in order to support the touristic city, the safe city, and the mobility city. And of course, this will serve the vertical customers, which are the hospital, the school, the museum, or the municipality of Turin, or the airport of Athens. So this is the overall architecture of the project. So how does this link to the different, let's say, components of 5G Tours and 5G Eve? So on the top, we have the tenants, which are the vertical providers. And on the bottom, you have the 5G Eve platform. And actually, we need to make these 2 communicate together in order to meet the 13 use cases. So basically, you have a tenant, for example, the hospital. So in order to communicate with the hospital, you need what we call a service layer, which is a sort of translator between the infrastructure and the tenants, because they don't speak the same language. Okay, so this will allocate slices to the different services that the tenants require. And then this will feed into the different elements of 5G tours in order to support the 13 use cases. So for example, we have innovations around enhanced MANO that use elasticity innovations. We have innovations around AI-based data analytics. And we, as I said, we have innovations. Can you mute, so please? Yeah, we can hear you, Rodolphe. Okay, so these are the three components, and then this will communicate with the 5G Eve platform, and we are working with 5G Eve in different manners in order to use the platform either directly or using the blueprints, but maybe the details are beyond the scope of this presentation. So this is as I said, the overall architecture, and the idea of 5G tours is to serve different tenants and to satisfy different use cases with sometimes conflicting KPIs at the same time, which is actually the added value of these demonstrations. As I said, we have many tenants. So for example, the school is a tenant, the airport is a tenant, the hospital, we need to communicate with the hospital and do the operating room. In Turin, we have the municipality of Turin that runs the museums, for example. The museums, we need also to communicate with the museums, for example, in order to have remote visits. As I said, in this COVID-19 crisis, being able to visit the museums remotely is an added value. So these are the type of tenants that we support, and this is how they communicate with the 5G Eve platform. Okay. So this is a project, actually quite large project with a lot of partners, and I wanted to show you, even though I don't have time to go through everyone, but to show these partners and to thank everyone for their contributions, and also to thank Manuel and Mauro for the fruitful contribution that we are having and collaboration that we are having with 5G. Yeah, so this is the end of my presentation. I think I have respected my time limit. And,
absolutely.
Yeah,
absolutely.
I leave it to you, Manuel. Thank you.
Very good overview. I will again project the slides so that we have the agenda with us. Okay. Okay. So yes, I think we are doing well with time, and it's important because it's so many things in the menu today that we are still giving a lot of time to the demonstrations, to the actual demonstrations. As you see, we'll have three demonstrations. The first one is on smart parking use cases in Athens International Airport. The second one will be on augmented tourism experience related to the area of Torino. And then the third demo is on teleguidance for diagnostic and intervention support. We will start now. I want to contact now and give the floor to the Greek team. Vangelis, are you ready to take on for the demonstration?
Yes, Manuel, thank you very much. My colleague Ioannis will share the screen in order to not to switch between many times between the different colleagues. So,
excellent.
Okay, I will share also my screen. Okay, okay, we will start with the first. Thank you very much also to Bert and you for the introduction. We will continue with the first demo. It's about the smart parking. And me, together with my colleagues, we are going to present you this demo. So I start with a small introduction about the demo, about the use case. Then Ioannis will continue with the actual demonstration. And finally, Nelly will present the demonstration of this use case, which is the actual deployment in the Athens International Airport. So I'll start with a small intro. This use case it's about the smart parking in Athens International Airport. In this use case, we are working a lot of people. You can see in the bottom. So I go to the next. If we go to the next slide, first of all, I make a very small introduction about my company, Wings. Wings develop a product for several use cases on different sectors. So we develop products about environment and air quality, and we have the Wings devices that we validate in 5G projects. We are involved in utilities sectors with the Artemis platform that we also validate in 5G. We are also participate and develop products in infrastructure and transportation, like the smart parking demo that we are going to demonstrate today. And we develop the WinSpark device, and also we develop some more enhanced 5G capabilities in which we validate 5G tours. And finally, we have some devices that are related with food and aquaculture, and we validate this in 5G hard. Also, the company develops infrastructure components like diagnostics, orchestration, intent-based networking. Two of them we have the chance to demonstrate today. Just a small overview about this smart parking use case. The use case is comprised of a set of parking sensors that are located in a parking space. In our case, these sensors are located in the Athens International Airport. These are the WingSpark sensors. We have the WingSpark platform on the other side, which contains the intelligence for forecasting parking availability, for calculating the available parking slot according to some specific criteria, and also for the optimal routing of the user to the specific spot. And also this platform provides two interfaces, one to the driver of the car, it's a mobile application, and the other a web-based dashboard for the parking facility management staff. And inside the two, we have the 5G network, and we validate how this use case is realized in a 5G environment. So if we go to the next slide here, in this complex, let's say, figure, you can see the different elements. You can see elements that are coming from the 5G, like the 5G infrastructure, like the interworking layer of 5G, and also some components that are based on this 5G infrastructure, and we build on top of this, which is the 5G Mano and the 5G Tours diagnostics. So just to go through a little quickly, let's say, on the top part, we have the 5G portal, in which we can create a design test and then execute the test in the testing and validation environment of 5G. This we're going to demonstrate you in the first phase of our demo. Then we have the interworking layer of 5G. We have the multi-site network orchestrator. We communicate with the OSM for the initialization, creation, and the deployment of the different VNFs that we need in the test. We have the runtime configuration for the real-time configuration of the test. We have the central Kafka server, which collects the metrics and the monitoring part as well. And then at the bottom, we have the infrastructure that is located in the 5G Greek node. So on top of the 5G Mano, we have the 5G Tours AI enhanced Mano, which is a component which is built in 5G Tours. And this we're going to demonstrate in the third phase of our demo. And also on the other part, we have the diagnostic module, which is also based in 5G diagnostic module, but it's extended in order to realize a real-time diagnostics functionality. Also, you can see that we deploy the smart parking VNF in the OpenStack using the 5G Mano and 5G Tours AI enhanced Mano, and also the parking sensors. So if go to the next slide. Here we will start the actual demo presentation. So I would like to thank you from my side, and I give the floor to my colleague Ioannis for continue this demonstration.
Hello also from my side. So for the phase one, we will show you how the smart parking service deployment will be onboarded from the 5G portal using blueprints and various descriptors. And we will see that the OSM will deploy this service as a VNF, as described in a specific MEC, and also check that the service will be up and running in our system. For this, we have to go to the 5G Eve platform initially and onboard the blueprints that we have designed. Also design a specific experiment that we want to schedule and execute. And the scheduling and execution will be done also in different steps of the process in order for the end to deploy the services and have the orchestration manages every service that we have in our system. So for this, I will go to the 5G Eve portal. So this is the link to go and visit 5G portal, and I can log in with my credentials. So here you see that we have different things that we can do at the 5G Eve portal. We have the design of the experiment, the request of the experiment, management of the experiment, and manage the site. So we are at the Greek side right now because we are deploying everything on the Greek node. And I can click on the first one in order to onboard the vertical service blueprint. In order to save some time, we will not onboard right now, but you can see from this list that we have different and multiple blueprints already onboarded, and you can do this with some steps as you see here. Also to mention that 5G Eve has created an extensive user manual for interacting with portal, so it is easy to follow these steps in order to deploy everything. At the end, we can go to the request experiment and design a specific experiment. So here we have already designed one in order to save some time, as already explained. So we can go at the end in order to schedule and deploy the application. So right here, I can create a parking application. For example, select the one experiment that we have created before and use also the Greek node for wings and select today and schedule it to run until tomorrow. So if I click submit, you will see that we have some success on the scheduling, and also right now the site manager has to accept this experiment in order to deploy the application. So after the site manager accepts this experiment, we can deploy it by clicking one button right here. And in order to save some time, because the service can take up to 15 minutes to be deployed and configured automatically from the system, I will show you how is the end result. So right here, as you can see, we are on the OpenStack on the system that manages the VNF. So we have one VNF, which is the parking, and two other VNFs that are some applications that are already running at the airport. Also, this is the open source Mano system that orchestrates and manages everything. So you can see here that everything is running and configured. As a last step, I will go to the MEC itself. So you can see that we have some internal IPs that the OpenStack has created, and the application is running correct. So 2, for example, out of 6 occupied the parking spots right now. So I will continue with the next phase, which is the phase that we do some performance diagnosis. So we have deployed the application using the 5G portal, and we have created the diagnostic module that monitors the service performance with various metrics. Also, we will generate an impairment in order to check that the system can identify and diagnose the impairment using unsupervised algorithm. So for this, as already explained, we have the smart parking application, and we have also a device that sends packets to the application itself through a relay. So there, we introduce a fall injection to the relay in order to check that the algorithm will find out the impairment. So for the algorithm itself, we have this self-organizing map system which using our supervised learning, and we have some heterogeneous metrics. So this is system metrics, application metrics, network metrics, various metrics are fed to the system in real time by the different components in order to check the service that is running and diagnose the problem. So for this, we have also created a demonstration. Here is a little complicated, but I can shortly explain it. So on the top left, we can see that we have some nodes. The health one are with green, and the ones that are not so healthy are the ones with the red. And on the top right, you can see here that we have some nodes and neurons, and based on their distance, we can assume that are healthy or not based on the algorithms that are running, and also some live metrics that I will show you shortly. So if I run the demo, you will be able to see right here that the system is running. After a while, an impairment will be generated, and we will see that the one node right here, the relay that we have the impairment, has become unhealthy, and the metrics, as you see, CPU, RAM, disks, are going to 100% right now. So the device and the relay are showed in red, as they are far away from their neurons, as you can see also here, if I can move this. And now the impairment has stopped, so everything comes back to a normal stage, and the nodes are healthy. So the system identified where the problem was, and which nodes had the problems, and the live metrics from these nodes. So this is a diagnostic tool that is running in real time for every service that we have created. And for the last phase, I will show you the automated deployment of a new critical service application. We will use the airport evacuation use case for this. So we have a critical service that requests resources, various resources from the system. And we have various metrics, KPIs, SLAs, that the verticals have provided in order for the AI-enhanced manual algorithms to decide and perform all the deployments and migration actions that are needed. In order to accomplish this, we have created a component on top of 5G-EVE that extracts information from the OSM for the VNFs and network services that are running live from the system. And also we have created some custom exporters data shippers that are getting metrics from the MEC itself, from the VNFs that the applications are running, and they are feeding back to the AI system in order to evaluate the data and trigger actions. So for the demo storyline, we have the three different applications. So we have multiple applications deployed right now at the MEC, and if something occurs, for example, a fire occurs at the airport, we need to evacuate. So we need to enable the airport evacuation application. So based on that, the AI enhanced manual will take care of everything. For example, it can move or terminate the applications that are not non-critical, for example, the parking application, or move them to another MEC in order to free resources and make sure that the airport evacuation application will run smoothly and based on the SLAs that are provided from the vertical that has created this critical application. And then we will see that the airport evacuation application will be deployed automatically. So in order to show you this, again, I will come here. We have created a module in order to showcase this. So we have here different resources for the network services itself, for RAM, storage, and for the MEC. And you can see for the RAM resources, right now, we don't have enough resources to deploy the application. So if the fire occurs, as I said, and this can be done, of course, automatically. So for example, it can be triggered by the system itself at the airport. I can trigger it right now manually. So I will trigger the airport evacuation application. And we will see after some time that the AI has already found the non-critical application and has terminated in order to instantiate automatically the new airport evacuation application so it can run without any problem. And also, you will see that the values have changed. We have created a new application here after a while if everything is running and configured. And the new application will be up and running without any problem also here at the OpenStack. So for example, here you can see that we have an airport evacuation application. The smart parking has been moved to another MEC or terminated based on the evaluation that the AI enhanced manual has created. And everything is up and running with the new applications automatically by using the algorithms from the AI system. So this is the phase 3, the end of the phase 3. And I will give the floor to my colleague Nelly in order to show the phase 4, which is the actual deployment and operation of the use case smart parking at the International Airport of Athens.
So thank you, Ioannis, for that. So let me share my screen in order to show you the video that we have prepared. So as Ioannis said, I will present the video that we have prepared for the use case deployment at AIA. So here we can see the system overview. Where the input from the parking sensors is transmitted via narrowband IoT to WinSpark Cloud platform. There are mechanisms for data analysis and forecasting of parking availability and optimal route calculation. There is also a mobile application for the drivers and a web-based dashboard for the parking facilities. In this scenario, the sensor detects the state change from occupied to free and transmits the information to WinSpark Cloud platform. This change is also depicted in the dashboard in real time. The parking facility management staff can also view a list of sensors, as well as details regarding their status, their battery level, their location, etc. Finally, the staff can receive real-time notifications for sensor malfunction or maintenance. The driver can log into the application as shown here and access a personalized user interface where he can view parking availability in real time, as well as request a parking slot and receive the optimal route to the suggested spot. So this was all from my side. Thank you all for your attention.
Thank you so much. Thank you so much. Very, very great presentation. Now we can open for one or two questions from the audience. I cannot read from the chat, but if anyone wants to take the floor and ask our colleagues, it's the moment. Okay, maybe it was super clear. Can I ask you something? I would like to know from you, with the privilege point that you have as common partner to 5G and 5G-TOURS, what was the one component of the platform that you were using that saved you most of the time and helped you focus on your use case?
Hi, this is yes, Miguel.
Yes. For just one answer from my side is that of course we use the testing validation platform of 5G, so we don't spend time on let's say making the framework of collecting measurements or validating the things, etc. And also the framework that let's say comes from it's responsible when you design, let's say, experiment and trial, how this automatically communicates with the orchestrator, the local orchestrator, the OSM, in order to deploy the VNFs based on what we define in the portal, let's say. So at this part, I think we gain a lot of time. Otherwise, we need to, let's say, to build this from the scratch, let's say. This is from my side.
Thank you, Evangelis. So, unless there is any other question, it was an amazing presentation. I want to really thank you for all the effort here and for the great progress. Then we will move, I propose, to the, because we are on time and we want to follow on time, we will move now to the second demonstration on augmented tourism experience. And I would like to give the floor to Enrique Quiroz from Athos. Enrique?
Hi, I'm going to share my screen.
Good, go ahead.
Okay. Hello, everyone. Today I'm going to talk about how 5G and augmented reality technologies enable new enhanced tourism experiences in the context of smart museums. So new technologies such as 5G are changing the way for new products and services, offering new possibilities to provide enhanced experiences to the visitors. The augmented tourism service will allow people to interact with 3D models and multimedia artifacts present in touristic places, providing new ways to consume artworks. This use case takes place within Palazzo Madama. It was the first Senate of the Italian Kingdom and is a building full of history. The mobile application of augmented tourism offers to the visitors a guided tour of the museum enriched with multimedia content, augmented reality experience, and other information to improve their visit experience, or working on 5G network to access to all the content fast. So 20 beacons will be installed in different rooms of the Palazzo by TIM, Telecom Italia. The beacons emit an ID that can be read by any closed device. This will enable our application to know what is the current room and offer the visitor customized content about it. Also, team will use this information to calculate the crowding level of every room of the museum in real time. The visit has 4 stages. In stage 1, museum visitors begin the experience. The visitor gets close to the beacon installed in the main hall. So that way, the application installed on the visitor device gets to the beacon ID of the hall and open the welcome panel, showing dynamic content to the visitors, like the crowding level per room and a suggested tour. In stage 2, the visitor enters in one of the museum rooms. Then the application scans for beacons and sends the ID to the closest one to the backend. The backend identifies the room where the user is located and returns related pictures, videos, audios that will be shown to the user. And the third, the stage 3, visitor explore artworks. The visitor approaches an artwork, then the application scans it and recognizes it as a target. So now, from Know It, the visitor will be able to select the multimedia content to consume, interact with the 3D representation of the artwork, like move it, make it bigger to see hidden details of the artwork, or rotate it. And finally, they can select the artwork as favorite. So the multimedia content can be consumed later, like outside the museum. And finally, the stage 4, visitor leaves the museum. At the end of the visit, the application will suggest to the visitor further places of interest and several mobility solutions to reach them, on foot, by bus, with car sharing. By interacting with the smart city services that provide both open data, like bus lines, opening hours, information on museums, but also measures like pollution, weather, traffic, availability of bike sharing, carried out by an appropriate network of IoT sensors that will be installed in the Piazza Castello area. So, well, this is the architecture diagram. I'm not going to enter in detail about it unless there are questions later, but the mobile application has been implemented in Unity 3D and Vuforia for Android. So now I'm going to share a short video. Okay, so this is the application. This video was made by one of my colleagues at his home, as we cannot go to the office due to COVID. So here we can see the login panel. Here the visitor can register themselves too. Creating a user is just needed to set the chosen language and the list of favorite items. Not sensitive data is set at all. So this is the welcome panel. It appears automatically the first time the user enters in the hall of the Palazzo Madama. As I mentioned before, there are many beacons distributed by the museum that will help our app to know where the visitor is in every moment. In this preliminary design, there are 3 tabs. One for the welcome screen with a message from the museum. This is this one. A second screen with useful data, like the opening hours and contact information. All the content will change in the future after contact with Torino Association. And the third tab, that is the most interesting one. This screen is an aesthetic map with some dynamic elements. The design will be improved in the next iteration, but the behavior will remain the same. This has 2 indicators. Red labels indicates the crowded level of every room in real time. This value is calculated by our partners of Team, Telecom Italia, and we can check those values every time we need them. The other service that Team provides us is a personalized tour based in the current crowding level. Right now, those are the blue labels that at some point we are going to change to arrows. Every label shows which will be the next room the visitor should go, and it's calculated specifically for every user according to the current situation of the museum. We can scroll and see also the second floor here. I'm going to jump. Okay, so now we start with the item recognition. As you can see, the application immediately recognizes the picture and reacts to it. We are using pictures here in the demo, but it will work with the actual items of the museum. We can see the name of the object in the top left corner, and we now have a new menu on the left with a few buttons. The number of buttons will change depending on the media that we have available for that artwork. If we click in the 3D button, we can see the 3D model and rotate it freely. This 3D model and any media content present will be downloaded in real time on the device using 5G connection. The second button is the information button that makes appear a panel with extra information about the current artwork. Now we can see that even when we look in outside the target area, the application will keep the object in their place. So they are not being lost. Also, we are free to move them as we want. And if we like a specific object or any of them, we can add them to favorites. So here it is. Now we are going to move to a new artwork that have more options. So this new artwork is like a teapot. And it has the two first buttons remain the same. One is the 3D model that is being downloaded. And the second one is for the information. But also we have two new buttons. One is the third one is the video related. It will be appearing right now. So it shows a video related with a specific artwork. The video streaming is fast thanks to the FAC connection. And finally, the last button is the audio button that will trigger a digital guide that will talk about the artwork that we have selected. The guide currently is just a placeholder, and we will work on this functionality the next year. So now we click on the favorite section. Here we can see a list of objects that we previously have added as favorite artworks. The most interesting use of the functionality is to use it later at home. As this part of the application is VR and won't need any interaction with any items of the museum to work. So we are free to use it wherever we want. We can see now the first, this is the actual room where the selected object is in the museum. We can rotate it and watch it freely. Again, this object has been loaded in real time. It wasn't stored in the application. And then if we click on the 3D button, we load the object and we can watch it in detail in every angle. This way of watching the content has its advantages over the physical ones, as we can watch like the base of the object, for example, and we can see details that normally are not available to the visitors. And if we click on the information button, we can read again some information related with the current object. So this is the favorite section. Now let's see how the beacon system works. As we don't have a physical beacons at home to play with them, we are emulating their signal with a smart dot app. The signal emitted is identical to the one from the beacon. So here my colleague Jordi is activating the beacon signal. And immediately we can see that it activated a new menu on the right that will change every time we move to another room of the museum. Every room has an associated gallery of pictures that we can watch. Here we can read a general description of the room. And finally, we have an audio guide that we can listen while exploring objects or walking around. We can keep exploring the museum while we listen this audio guide. So every other options that we mentioned before are compatible with keep listening to the audio guide. Well, we are more finished. Now we are going to restart the app to log in with a user. because the previous one was choose English as preferred language, so we are not entering again with another user that choose Italian. So we can see how all the tests have changed to Italian. That's just to show the multi-language functionality. So this is it. Let's continue. This is the service architecture. As you can see, all the services can be accessed from the Palazzo through 5G network. And internally, it's separated in different modules that interact between them, and that could be virtual machines or Docker containers. For now, we are flexible on it. And we have here, we can see how the integration with 5G Eve will be. Our services will have a layer to orchestrate the different modules that, as I said, it can be virtual machines or Docker containers. And we have prepared three different configurations proposals for hardware, from the minimal needed to start working to a quite generous production server. So that's all. Thank you very much, and please let me know if you have any questions.
Thank you so much, Enrique. Yes, we really want to encourage the audience to ask on this interesting use case that you have trialed. Any question from the audience? Okay, then we have a shy audience today. Enrique, can I ask you something?
Yes, sure. Go ahead.
I would like to know what gave you more headaches or more happiness in the integration of all this different stuff, because you have brand new applications, very specific devices, 5G behind. Is there any aspect that you would like to remark that caught most of your attention in the process?
Well, for what I think that will be a headache could be the final integration, because how is the actual situation because the COVID? As we are, this is very focused on the Palazzo Madama. We have a lot of doubts about how will be the installation of the sensors that we need to integrate, as you have said. Right now, we are showing just that a little part of the functionality that we have planned, and we relied in sensors. So if the sensor has to be in a specific place and this place is closed because of the COVID, this has some challenge to afford. And for the development, we are happy with what we have now as base, but we have very much to improve on the next year. So I'm sure we are going to face issues ahead.
Thank you so much. I think that it was actually the case, and that's a reflection that in this COVID period, basing some of the experiences in the ICT 17 platforms already deployed helped, because then there was a stable environment to simulate, to play around with 5G, real 5G, and that's a common thing that we are learning in the cooperation with ICT 19 projects. So only that, I think, was worth the effort. And I wish you very much a good ending of this initiative in the actual and final field trials. So thank you so much for your presentation.
Thank you.
Okay, keep doing well with time. Again, there's the chat board for questions that you want to address at the end of each presentation, or you can take at the end in the limited time we will have for the closer. So now, if we are also ready, we would like to hand over to Franz for the Teleguidance for the diagnostic and intervention support. Ian is probably ready for showing their demonstration. So we can see your screen, but at least I can't hear you. Now it seems to be showing up.
Sorry, double mute. Happens all the time. Very much apologise. I'll say once again, good afternoon and welcome to all. Thank you for having Work Package 5 along. As mentioned previously by Bell, Work Package 5 is based in Rennes and is primarily focused on health. So what can we do essentially to show the real benefits of using 5G to deliver healthcare in a more efficient and better way? To do this, we have a number of use cases which we'll run through. We'll run through two of those in the next few minutes. My colleagues von der Lang from Philips will talk us through some of the more sort of hands-on experience of using the probes, etc. BCom, who are our partner, also in 5G, building most of the network side, will take us through the architecture and the network stuff, because essentially that's not my forte. And there's some additional information from Nokia in terms of our work, or our current status of our work with 5G Eve itself. So, come on, computer. There we go. So there are 4 use cases essentially, and the whole scenario is of a chronically ill patient, somebody with chronic diseases, comorbidities potentially, gets critically ill. So this person is using monitoring devices because of their chronic illnesses, and these are all being collected via their 5G phone to Wings cloud. So Wings is also involved in Work Package 5 and does 2 of the use cases. So the person is being remotely monitored. That's not something that's something I'm going to demo today, but essentially that is one of the things, especially now with more remote monitoring being potentially required. But we'll see a lot more density of devices being required to look after and monitor people who have diseases. So the other one, and that is all about monitoring the patient themselves. So in our particular scenario, this patient does become ill and they need to go to hospital essentially. We are working with the CHU Rennes Hospital, which is one of the reasons we're in Rennes. And that is also, it's a very excellent thing, and also a little bit of a problem in terms of the local restrictions at the moment in terms of accessing healthcare facilities. Obviously, we've had to deal a little bit with that, but we're doing the best we can. Essentially, the next use case is optimal ambulance routing. That's to get the ambulance through the city of Rennes, through traffic, through all the traffic conditions, etc., to get an ambulance to the patient as fast as is humanly possible. So using 5G technology, city sensors, additional IoT sensors to make sure the ambulance is always going on the fastest possible route to get to the incident. Once the ambulance is there, what we're going to look at today primarily is a remote intervention. This is the ability for the staff at the ambulance be able to use ultrasound probes, augmented reality glasses, etc., to basically be guided by remote experts to position the ultrasound probe to help get very, very critical, very early diagnosis on scene, sometimes quite often, sometimes very life-saving information in terms of internal injuries being diagnosed and caught so much earlier than if they were to wait until they got to the hospital. Fons will talk more to that specifically on how that helps in a moment. And then we use the same technology, same use case essentially to make sure the ambulance gets back to the hospital, again, by the fastest possible route. And once they're there, the second the fourth big use case that we're looking at is essentially a wireless operating theatre. So at the moment, modern operating theatres are very expensive to build, they're very hard to change. And we're looking to bring 5G technology into that wireless operating theatre to enable high definition streaming of all the various images that are required, and get rid of the wires. So it helps with cleanliness in the operating theatre. It helps with the ability to reorganize and manage the operating theatre. And we'll get to some of that in the next few slides as well. Just a very quick overview. I think Belle mentioned earlier, we are in France, not Sophie Antipolis. We actually have the BCom premises in Rennes. We also are going to, when we can get there, install another radio access network in the CHU hospital itself, in one of their spare theatres or their learning theatre. And we are also using our facilities, Orange facilities in Château, to provide the OpenStack ONAP orchestration to the remote site in Rennes. And all of this infrastructure, some of it's been in place through 5G Eve already, some we've had to add as part of 5G-TOURS to enable the various use cases. So with that said, I'd like to introduce my colleague Fons de Lang from Philips, who will talk us through the next few slides on ultrasound. Thank you, Fons.
Okay, can you hear me?
I can.
Yeah, okay, great. Okay, so the next slide, actually what we want to show here is that we're not just working only on technology, but also on doing the real user tests. So really understanding that what we are creating is really useful to the end users. In our case, we actually work with real doctors in the ambulance, but also with the regulator. Because we had this COVID-19 travel restrictions, we did some of these tests in the Netherlands, in Eindhoven. So these are really use case related. Although we did it in what we call at the campus, high-tech campus, the 5G hub. So there is 5G system being developed, which we did not use in these tests here, but we still want to be sure that everything is usable to the end user. So what did we do? We used the Phantom, as you can see in the picture, and actually we had a regulator, a medical manager role, who was guiding remotely a number of paramedics who actually have to hold the probe and do a certain examination. And these paramedics actually are not really, not all evenly experienced. So we had some who had only very little training or no training at all, and also a very experienced paramedic, which relationship to doing ultrasonic diagnostics, to understand if guidance from a remote expert actually works or not, if it's useful, and what you need there. And what we did mostly is we did tests on the abdomen, doing what is called the FAST protocol, which is about focused assessment of trauma, which is, for instance, free fluids, detecting that, checking the liver, the kidneys, the bladder, and so on, to see if there's internal trauma. Next slide, please. So, so this is actually a bit crowded as a slide, but it shows the main findings. You don't want to spend too much time because there is a whole deck of these slides actually. But what you actually see here, the experience, it shows the experience and skills of the paramedics from low to high, from left to right. You see the increasing experience, and that has to do with what makes a sonographer a good sonographer. That has to do with correct probe placement and correct image interpretation. These are two different things, but very difficult. Both are very difficult to do. And how the role of video guidance, let's say an expert in the hospital, could actually guide to effective guidance of such paramedics, even those who have not so much experience. But actually what we saw that you need some basic experience, otherwise you don't understand the language, what's being said to you, to move the probe and do the tilting and rotation and so on. But still, then it is already useful after this basic training that you really need supervision. So both for placing the probe correctly, and for that you need video to do it correctly. And so the medical manager, the regulator, can see what's going on and can instruct the paramedic to move and change the probe position. Although we see that for very tiny movements, which is crucial to get a good image quality, there for that purpose you need more than that than just simple video camera to, or you need another way of looking at the patient. So what we see that the experienced paramedics who are very good at sonography, they actually also need video support, because sometimes you have difficult cases, and also sometimes you have cases that don't happen a lot, so you need support there as well. So we see that video streaming is really, real-time video streaming is really important and interesting to show the probe position to the medical manager, and also then show the right spot on the patient's body. Well, but as I said, video is for the fine-tuning not really well suited. So you can block the view because the probe is placed in a position that the video camera cannot actually look at it, or you have to change the video camera position. But what we're doing now also is working with AMA system, expert eye system, that allows you to wear smart glasses that prevent blocking the view. And also you can actually see in your glasses the ultrasound and the video at the same time. So that's something that we're currently working on. That's it.
Excellent, thank you, Fons. And I think that leads nicely into the demo that so far we've managed to create. And this is where I'll introduce Eric Gertel from BCom, who in one of our most recent face-to-face meetings, or partially face-to-face, partially remote because of the circumstances, the initial demo that we're able to do and run us through that and some of the architecture behind it. So over to you, Eric.
Yes, hello. Yeah, so I will present, yes, the setup in BCom premises end of October during the technical setup with partners involved in the use cases, the two use cases here. So the use case 7 on use case 8 is actually the teleguiding and wireless operating room. Just to use case 7 and use case 8 have a number of the Work Package 5 tours, Work Package 5 of the 5G-TOURS. So we do a demo for the two use cases here. As at this step, they are very close in terms of networks. So it's why we combine the two use cases in this demo. So this demo was to build a 5G NSA network in the lab environment in BCom premises, composed by the core network, which is become Wave 2 release. This core network was connected to the RAN, Ambience 5G RAN, in the band of 3.5 gig. We used two devices for that, one CPE Huawei Pro 2.5 gig on one Samsung Galaxy i90 5G. And at the edge, we could connect two servers for the application connected to the UPF. One was the AMA Expertise application, and one was for the decoder for the ultrasound video stream. And then the main target of the demo was to allow simultaneous uplink transmission through the network. Ultrasound probe, which will be used for the hospital at the end, connected to the CPE, and the AMA smart glasses connected to the Samsung Galaxy i90. To see the video and to see the pictures, we use two remote monitors while connected to the video decoder on AMA servers. So that at this stage, just a word that the medical people attending the demo, of course, were not able to analyze the medical picture. It was not the target of the demo. So then, next please. So then in terms of architecture demo, so we have a drawing of the architecture. We put some pictures of the equipment used for the demo. So we can see here we have an ultrasound here on the top left of the diapo of the slide, which ultrasound is connected to the DICOM RTV module to compress the data. And then this module is connected to the CPE 5G, CPE Huawei 5G. On the bottom left side of the slide, where the smart glasses. The smart glasses are connected to the Galaxy i90 5G smartphone. And on the right side, we'll have this 5G NSA network composed by the 3G.5 RAN Amarisoft. And then we have the decoder module on the AMA Expertise server connected to the UPF. So we can see here some the pictures of the equipment. So if we go to next slide, just to have yes. So just to focus on this equipment for the 5G NSA network. So we have on the right side the 3.5 gig RAN Amarisoft with the antenna. We can see here in the middle the bottom wave, the BCom wave core network for the control plane or user plane. On the left side, we have the AMA Expertise server connected to the UPF, and as well the decoder you can see on the black screen connected also to the UPF. So for the network, we could make some quick measurements to try to measure the throughput we can have from such configuration. So we put the CPA 1 meter from the 5G antenna, set at the minimal output power, and we could measure such throughput of in-downlink on uplink. So downlink it was 180 megabytes second, and uplink 70 megabytes second. But the measurements of the latency was not so stable. We can only get some value from 30 milliseconds up to 200 milliseconds. So it's just a measurement done with speed test tools. If you move to the next one. So okay, I said that we have two remote monitors, so to display the AMR smart glasses view on the left side through 5G network, and on the right side we have the remote monitor ultrasound with a decoder. So this one, of course, is on the same room for the demo, but at the end it should be remote connected to the hospital or to the for the teleguidance use case, so that the doctors on the hospital will be able to see what's going on the site where the ambulance will be connected. If you move to the next one. So as I said, we can see here that we have the streams we can see here on the screen. We could transmit the streams for the smart glasses, so which will be worn by the surgeon in the use case 8 in the wireless operating room, or by the emergency doctor, which will be for the use case 7. And then in the same application, we can combine the Philips probe streams with the Lumify application to be also sent to the by the emergency doctor to the remote doctor in the hospital. So then we could also make some measurements with the ultrasound probe to be used in the hospital for the use case 8. So as you can see here, we have the components like TV takes to compress the video. And this equipment was configured to encode the video flow at a bitrate of 30 megabits second. And then we have a tool, a specific tool for this application in terms of the probe, between the probe itself and the remote monitor. We could measure the end-to-end measure latency. Of course, it will include the latency due to video coder and decoder, and the latency, of course, due to the 5G NSN network. And such measurements were done during 9 hours. And you can see on the picture here, on the graph here, you can see the duration and the measure latency between the two equipments. So this graph is showing latency is going from 117 milliseconds on to 133 milliseconds. So if we remove the latency of the decoder, video decoder and decoder, which is 30 milliseconds each, we have a latency of the 5G network between in this configuration between 57 milliseconds and 73 milliseconds. Okay. Next, please. Yeah, so just a word for the conclusion of this demo. So as I said, this demo is mainly to show and to set up some configuration to allow the transmission of the smart glasses, and at the same time the video stream for the ultrasound probe encoding by the DICOM RTV module. So we could make it. Of course, we have a lot of things to do to complete this demo, and as you can see here, we have many things to do to improve the performance of a network by, for instance, integrating 5G RAN network instead of Amarisoft, which will improve the radio performances, and then also increase the quality of the video streams with the smart glasses on Lumify application sharing and other actions to do. And one also, it will be to use the 5G platform to integrate this network through the 5G platform. So for that, I will give you the floor to Thomas, who will present what will be done for the 5G integration.
Okay, hello. So actually, the integration with 5G is done in 2 steps. First, we will integrate with an app for the orchestration, and then with the portal use the full 5G stack. So the first part is mostly done. We will use an app to deploy the use cases. So the RAN the Nokia RAN will be activated by an app. Then the core network, which is deployed in Become data center, will be also deployed through an app. And the other services will be mostly a matter of activating the network, because they're using their PNF that use a dedicated hardware. So they will not be deployed through an orchestrator. And also 5G will use the 5G infrastructure to interconnect the different sites through VPN. So essentially, Orange and Become were already connected, and then we added another VPN to the hospital. So this means that we need an upgrade of an app multi-site feature to add the hospital, and Become was already part of the 5G infrastructure. And then the deployment through the portal, we are currently writing the blueprints to use it. Okay, so you can move to the next slide, please. Yeah, so we have here a picture of the integration of the two use cases, 7 and 8. So the red part is the 5G infrastructure, which was already there. So the on-app instance in Orange and the deployment of the core network in Become data center. And what is added for 5G-TOURS is the user plane. So the one on the left, which is in the hospital, connected through the VPN, and which will be in the operating room, and the one on the right, which will be in Become, with the RAN connected to the ambulance and the UPF in the data center as well. So that's the integration strategy with 5G.
Okay, thank you very much. And I think with that, we are done in terms of what we want to present today, and obviously open for any questions that the crowd or the participants may have.
Very good, great presentation. Thank you all. It would be great if we can get questions from the audience.
There we go. Perhaps if in the absence of some questions right now, just to expand, I guess, on the two-stage approach to integration with 5G Eve. So essentially, you know, we've had to build some temporary measure or sort of temporary network as such that the Amerisoft is not the long-term plan. But one of the issues that we face in France specifically is the question of frequency. So we have to use a specific 26 gigahertz frequency in France. It's imposed by the regulators. So that's meant that although some of the initial deployments have been done on software-based and using more commercially available devices, the long-term plan, the Nokia RAN that we're looking to install will be 26 gigahertz. That conforms with the various requirements in France specifically. That's both a good thing and also a slight hindrance in terms of, and certainly in the current situation, it's meant that getting the equipment itself, the physical antennas to get them installed has also been slightly delayed. So we have had a few knock-on effects. In the meantime, we've worked very hard, Become especially worked very hard to get the network in place to allow the initial integration to take place of all the various components. Because once all those components are in place and they're pulled together and are able to demonstrate the various features of 5G in terms of latency and all of that, then that's when I think we'll be able to put forward a much more compelling and rich demonstration. But until then, we're doing what we can. So. There we are. And if there's any questions, I can answer them now.
Very good, Ian. I guess you can hear me now.
Yep.
Yeah. Very good point on your next steps. If you want to comment a little bit more on your path to probably 5G SA, I think it would be interesting if you can share on your outlook on that.
Well, 5G SA, well, 5G SA is part of the plan in terms of that's where we need to get. We don't have a specific delivery date in mind because everything is, we basically our starting point has been changed because of the various factors that have come in. The plan is to try and get there, but we don't have a specific date in mind yet. At the moment, we're going with NSA, and I'm throwing around network terms like a network engineer, which I'm not. But essentially, that's where we are. I guess if Eric or Thomas wants to comment any further on that specific question, I'll be quiet.
Yes, I mean we're developing the standalone core in Become. So the plan in the roadmap, it should be available at the end of next year. So if there's no delay, we will use it in 5G-TOURS.
Okay, and just another question from me. I could see so many disciplines involved in this project. Would you like to highlight any of the main learnings of this cooperation between so many different partners?
Well, I mean, maybe we should go through everybody involved, but certainly from my point of view, I think one of the key things from the start has always been the involvement of CHU REN and the healthcare professionals there. Rather than just, well, I say just, rather than engineers and technicians getting together and making very cool stuff with 5G, we've involved the doctors, as Fons mentioned earlier, they had real doctors come into their site in Eindhoven, because what we want to make sure is that it actually does enhance the provision of healthcare, as opposed to, just give a technical advantage or a technical difference to providing healthcare, because at the end of the day, there are many examples throughout healthcare, and I've been involved in healthcare standardization for many years, where a new piece of technology is perceived as being something that will improve healthcare, but actually when you put it in the hands of a doctor, they have a slightly different view. So, where possible, because of the various restrictions, we've had the doctors from CHU attend our meetings and come and give us their advice. So I think that's one of the key things here, is making sure that it's the right kind of technology for the right disciplines.
Yeah, and what I can add here is that the importance of the service layer that became more and more clear, that is from a application provider view. You don't want to know all the basics of using the 5G network. You want an easy to use interface, but with a lot of features anyway. So dynamic slicing is one of them, a very advanced feature, of course, but something from a healthcare provider view, very interesting. So, but that would be the interface, which we are also working on in 5G-TOURS.
Excellent. Thank you for your comments on this. So I think that we are done with all the demonstrations. We have a few minutes to wrap up and collect any questions that we can get from the audience. I would like to get a little bit more in touch now with Belle on your comments on what we have shared. Anything you would like again to remark or to comment in the having to do with the next steps in the world we happen to live in, this complex world where we are working like hell and we have so many restrictions in the normal things that we took for granted several months ago.
Yes, yeah. I have an issue with my camera, so I had to switch to my desktop, so you'll not be able to see me. But yeah, so thank you for the question. I mean, it's an important question because in such a project, we have like 36 months in order to plan many steps, and actually, we in 5G-TOURS, what we did is that we had a sort of phased approach in which. At the beginning, we tried to run some of the verticals just to be able to run the verticals on sometimes smaller networks or local networks, sometimes using commercial networks. And as you can see, we are moving now to the second phase, in which we will have a full compatibility with 5G-TOURS. So today we have seen some of the examples of this work, and having this kind of smooth transition, we could decouple the two issues of getting the vertical to work, and then the second step will be more about the link to 5G Eve and how to use the portal and how to onboard our functions on the portal, which is a different kind of work. So my thoughts about the project is that, you can see from the project that there are many participants. First of all, within 5G-TOURS, we have people that speak the network language, and then we have people that speak the verticals language. And it's very interesting to understand how the two work together, because if we talk, for example, when we talk about requirements, how to translate requirements, some of the requirements do not mean the same thing for a vertical user and for the network expert. So we had a lot of learning while bringing together the verticals and the network, and it gives an overall view of the project, which is really interesting. And the other thing is working with 5G-TOURS or 5G-EVE, because we need to create functions, onboard them, and then work with you guys in order to plan experiments and make sure that we collect the right KPIs. So it's a complex process. And I imagine for you it's even more complex because you are managing 10 projects or so in parallel. So it's really a complex process, but I think we are delivering on it, and we are working as much as to the best of our ability, especially, as I said, with this COVID pandemic, because, for example, Ian was mentioning that working with the hospital in Rennes is a great experience, but it happens that in this particular time, we couldn't access the hospital for a long time. The same thing with the, let's say, the Turin museums. It's a very good experience because now we can see the, let's say, the use of having a use case in which you can visit remotely the museums because of this pandemic. So yeah, all in all, it's a good experience. We are midway through the project, and we already have some tangible results, as you can see, and we will continue working on this. And I would like to thank everyone who participated today, and to the broader sense, everyone that works within 5G-TOURS for the great effort, and to you guys for working with us in 5G-EVE. Thank you.
Thank you, Bel, and thank you, everyone. Not trying to have the final word, but really, again, expressing our thanks for the great work and preparation for this. It's really a pleasure as a 5G technical manager to be in touch with you for this. I think it's not only the platform, the 5G capabilities, all that we have deployed, but also the experience and the learnings that we can share with you and help each other, because that's how we have been working. You have been giving us good hints on things that we have to have in the platform, and we have been cooperating with you to be able to accelerate the pace of your projects. So that is really a very good experience. And yes, you are midway, but you have done a lot and you have showed a lot today. So congratulations again. So by that, I think that we are almost on time in the universal clock of our system. Only 2 minutes for finishing, but I think that we have covered all the objectives of the session. So thanking again all the participants, I think that we can close here. And of course, you can follow. I'm sorry, I should be sharing. Just a second. Okay. Okay, I found an issue to share, but now I'm back. Okay. Just to recall that, okay, and now full screen, and that the slides have been recorded and they will be available at this web page. And of course, you can follow the event in Twitter and follow the comments on it. So thanks again for a very good participation and preparation, and take good care of yourselves. Hope to meet you again soon.
Thank
Bye
you,
now.
Manuel. Thank you. Bye.